My talk is about the continental breakup and the propagation of the South China Sea. Presently, I have changed my affiliation to the Deep Sea Drilling Center in Guangzhou Marine Geological Survey. So, yeah, you are welcome to visit us. And South China Sea is here, located, surrounded by the subduction zones. So it's not a open sea, it's named the marginal sea. So its formation is closely related to subduction zone. You can see here for the West Philippine subduction zone, the Indian subduction zone, and etc. Although it's strongly affected by subduction, in fact, the Cenozoic South China Sea is believed to be formed by passive rifting and spreading. So unlike according to this map, then you can see that the Gulf of California was formed by the slab pool of the Pacific Ocean after the subduction of Farallon Plate. And South China Sea, in fact, was believed to have the similar history. So in its history, the subduction zone first subducted toward the northwest, but later, after a period of subduction, the slab pool makes the extending of the South China Sea to generate the Cenozoic rifting system, and later the seafloor spreading of the South China Sea. So in the mechanism, we believe that the South China Sea is a little bit similar to the present Gulf of California in the history. And therefore, we hope to know what has made the South China Sea break up and the propagation of the whole rifting system. And you all know that according to the former drilling history along the Atlantic margin, people named the breakup and the formation of the continental margin into magma pool and magma ridge, according to the involvement of the magma during the thin rifting and the early breakup stage. So we want to know what South China Sea should be classified to. Therefore, we carried out two expeditions, LDP expeditions in the northern continental margin of the South China Sea. So this is the South China Sea oceanic basin. And here is believed to be the transition zone from the continental margin to the early ocean. And you can see the red dots here are LDP drilling sites. So we made 7 drill sites from the distal margin to the transition zone and to the early oceanic crust. So these drilling sites give us a brief overview for the basement rocks from the distal margin to the oceanic basin. And you can see that in 1499 here, we drilled these thin rift sediments and the gravels. And the people, according to the sediments and the foraminifera, people believe that these sequences might belong to the Mesozoic sedimentation, but it's still arguable. And but in the U1502 parallelly, on the another profile, people found this kind of very alterated basalt. And later, further toward the drill site of 1500 and 1503, people find the fresh basalt here. So therefore, it looks like that's the transition from a continental rifting to a seafloor spreading is very fast. Means it's transition in a very shallow, very narrow zone, and we made a inversion with the seismic and gravity, and we found that the transition zone is roughly about 30 kilometers in the transect here, and therefore it looks like that the drilling in the South China Sea through neither magma pool nor magma ridge, but the continental rifting transition into breakup and seafloor spreading in a very narrow zone, and this process just happened. But after drilling, people still have lots of controversy toward how the magma will involved in the rifting and breakup process. Therefore, people proposed many different models toward how the magma was involved in the whole process. So some models like Lawson's model, they believe that magma just erupted very quickly in the very narrow zone to cause the breakup. But there are also many other models to believe that the magma have been working with the whole rifting process till it breaks through the continental crust to generate the spreading process. So in order to constrain this process, we make some exploration. First is along the main transect to deploy the OBS, the ocean bottom seismometer, to detect the velocity structure from the proximal margin to the seafloor area. So here are the stations of the OBS. And later we also carried out some magnetelluric investigation along this profile too. And here is a velocity profile collected by the OBS. And you can see that very interestingly, we can see this magmatic underplating is very thick below the shelf area, the slope area here. And the magmatic underplating just becomes thinning, but it's not continuous. And till in the transition zone, it becomes thick again. But later, the breakup occurred. You can see the comparative observation of the multi-channel seismic imaging here. So below the transition zone, there are also magmatic underplating. So, but it's not so thick. So we want to confirm that whether this magmatic underplating is thin rifting. And we make the comparison parallelly with the OBS profiles in the continental margin, both in the northeast area, and this one is our profile. And there is a boundary here. It's a very large fracture zone, and the western of it is very different. So you can see that underplating is very thin and discontinuous in the western part. But in the eastern part, there are lots of underplating and very thick. And usually they show the similar character to be thick below the slope and thin below the continental transition zone. Therefore, we set up the model based on South China Sea's imaging to name it the magma intermediate to be compared with the magma ridge and the magma pool end member. So South China Sea might be located in between. And also we constrain the underplating with the deformation on the seismic profile. And we found that below the very thick underplating, we can see that the early sun rifting sequences just being pulled up and eroded. And after that, the sedimentation just dripped over the whole section. So it seems that this magma underplating is occurred also during the sun rifting stage. And interestingly, oil company, they have some drilling in the sex to find some early sun rifting magmatic eruption in the Sac Basin. And also they found the deformation associated with the magmatic.
Jen, you're at 10 minutes now.
Okay, I will okay, accelerate. Therefore, we based on these observations, we propose that in the South China Sea, the breakup or the attenuation of the mantle might occur earlier than the crust. Therefore, it caused the underplating below the continental slope to be thick. And along with the expansion and the propagation of the mantle attenuation and the magmatic underplating keep working till the continental crust is thin enough to make the magma eruption to be breaking through the whole continental lithosphere. But this process we compared with Atlantic, and we found that the South China Sea has even more magmatic underplating than the commonly Atlantic tab margin. Therefore, we propose that maybe the pre-rift subduction might cause the mantle to be weak and also saturated to generate such a process, and also the huge amount of magma underplating. And this work is also proved by the numerical modeling by first subduction and then slab core. And you will observe the first mantle breakup and then the larger amount of eruption. And also we compared parallelly along the stretch of the South China Sea continental margin. We can see very different structure and breakup style of the continental margin. After comparing many of the profiles, we found that the South China Sea in fact broken up in two subcenters in the eastern part and the central part, and later they connected each other at about C9, that's about 29 million years ago, and then propagated even westernward to cause the fully connection of the breaking up area to generate the present spreading of the South China Sea. So that's all my presentation, and here is a summary. So the main idea is that breakup of the South China Sea is consumed to be typically depth dependent, and the mantle might be attenuated or break up earlier than the crust. And this process is believed to be associated with the subduction, pre-rift subduction. And the broken of the continental margin is not continuous initially, but later they just connected each other and to generate the present South China Sea. So I have to stop here. Thank you very much.
Awesome. Thank you very much for that wonderful presentation. Do we have any questions for Jen? I have one, actually a couple, but I'll start with one. Do you have any thoughts on why the magmatic structure of the two part of the rifted margin differ so much between the west and the east? Because you showed that map where the southwestern part has less underplating and the southeastern part has a lot. And I like to think it's not because of your sampling interval, like the density of your seismic imaging.
Yeah, you are right. First, there is a very large transform fault between the eastern part and the western part. And secondly, in fact, after reconstructing the Salton Sea to the pre-spreading stage, we found that the eastern part, in fact, located, especially this area located in the fall arc area
Okay.
of the proto-subduction zone. But in the western part, you can see that the Nansha area is very narrow in the east, but wide in the west. So the subduction zone, the Mesozoic subduction zone located southward of this area. So therefore, the western part located in the island arc area of the subduction zone, and which we believe that also maybe affected the rifting and the breakup and even the underplating process. But we still try to make the modeling, numerical modeling about this for whether the fall arc area has more saturated mantle to generate the differences between the eastern part and the western part, but didn't complete it yet.
Yeah, that's cool. Yeah, inheritance definitely important. It makes sense that numerical model is one really good way to test that. Okay, one other question I have, just before we let you go, is on the timing. I understand that from all your interpretations, it looks like it's difficult to independently, say, use geochronology, like age dating, to confirm the timing of arrival of magmatism into the lithosphere. Like, was it late stage indeed or early stage? But I also understand why, you would interpret the margin to be magma intermediate instead of magma rich or magma poor. But I do like Janreto Manascial's, own classification for magmatic characterization of rifted margins in this situation, because he seems like he's been proposing more of delayed versus early arrival of magmatism. And in this case, I lean more towards delayed arrival, but I also understand your interpretation of two-step. Like, it started to there was magmatism at some point before breakup finally initiated.